Imagine you want to travel to a galaxy really, really far away. Even if you traveled at the speed of light, it would still take millions of years to get there. But what if there was a shortcut, like a secret tunnel that could take you there much faster? That's the exciting idea behind wormholes. Wormholes are like tunnels in space and time that connect two distant places in the universe. Think of it like a shortcut through the cosmos. Instead of traveling for millions of years, a spaceship could enter one end of the wormhole and pop out the other end almost instantly. Now, wormholes aren't just something you see in science fiction movies. The idea actually comes from Albert Einstein's famous theory of general relativity. This theory changed how we understand gravity, and it suggests that wormholes might actually be possible. A trip through a wormhole would be a wild ride. Imagine flying through warped space and time, feeling strange gravitational forces, and maybe even catching a glimpse of other dimensions. Albert Einstein was a genius who came up with the theory of general relativity. He said that gravity isn't really a force, but instead it's caused by the bending of space and time. Imagine a bowling ball placed on a trampoline. It creates a dip, right? Well, massive objects like stars and planets do the same thing to space and time. Einstein's equations showed that space and time can be bent, twisted, and even folded. This bending is what we feel as gravity. But could we bend space and time so much that it creates a shortcut? That's where wormholes come in. Imagine folding that trampoline in half so that two ends touch. A wormhole would be like poking a hole through those touching points, creating a shortcut. Einstein's theory opened up the possibility that space and time aren't fixed, but can be changed and manipulated, maybe even to create a wormhole. There are two main types of wormholes that scientists have thought up: Einstein-Rosen bridges and traversable wormholes. Let's start with Einstein-Rosen bridges. These were first proposed by, you guessed it, Albert Einstein and another scientist named Nathan Rosen. They imagined these bridges connecting black holes and white holes. So, what are black holes and white holes? Imagine a place in space where gravity is so strong that nothing, not even light, can escape. That's a black hole. Now, a white hole is the opposite. Things can only come out of it, but nothing can go in. An Einstein-Rosen bridge would be like a tunnel connecting a black hole and a white hole, but these bridges would probably be very unstable and would collapse quickly. Now let's talk about traversable wormholes. These are wormholes that you could actually travel through, but here's the catch. To keep them open, we might need something called exotic matter. This exotic matter would have negative mass. That means it would weigh less than nothing, and it would push the walls of the wormhole outward, keeping it from collapsing. So, how do we make a wormhole? Well, it could happen naturally, or maybe even artificially. Some scientists believe that really tiny wormholes, much smaller than an atom, might have formed during the Big Bang, which is what created the universe. These tiny wormholes might still be out there, but finding them would be incredibly difficult. On the other hand, some scientists think we might be able to create our own wormholes using super advanced technology, maybe even using the strange rules of quantum mechanics. Quantum entanglement is a weird phenomenon where two tiny particles are connected no matter how far apart they are. Some scientists believe that if we could control entangled particles, we might be able to create tiny wormholes. However, we're still a long way from making stable wormholes that we could travel through. We need to learn a lot more about exotic matter and the universe before we can even think about building our own wormholes. Traveling through a wormhole sounds awesome, right? But it's not all fun and games. There are big challenges and dangers. Finding a wormhole is like finding a grain of sand in a desert. They are incredibly hard to spot. Creating one is even harder. We need exotic matter, which we've never seen, and it might not be safe. It could collapse, crushing anything inside. And there are unknown dangers: intense gravity, radiation, and exotic matter effects. Time might move differently inside. Wormhole travel is exciting but challenging. That's what makes science interesting, exploring the unknown.